The Ben Heck Show is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com. Hello and welcome back to the Ben Heck Show. In our previous episode, we began building Hackbots, robots that could fight each other. Felix, Karen, and myself are each building a different robot. We started by getting pre-built kits off the internet for the robot frames with motors. We then added our own remote control systems to each one of those chassis and got them moving around.
So today, in part 2 of that series, we're going to be putting weapons on our robots. So in the final fight, each robot will have 3 balloons on it that the opposing robot has to try to pop.
That sounds like Mario Kart.
Like from the Nintendo 64? I don't know where we would have gotten that idea.
All right, so Felix, Karen, and I are going to attach weapons to our robots. Let's get started.
Amazing hacks.
Where are my dragons?
Inspired designs.
Oh, look, I knocked some hot glue loose.
Regrettable acting.
I want to live in a world with Star Wars again!
Each week, Element 14's The Ben Heck Show brings you innovative projects using electronics, engineering, and more.
We went to Dig and Save to get some weapons for our robots, so we dug around in the junk to see what we could find. Karen grabbed a toaster so she can get the nichrome wire out of it to make a heated weapon. I grabbed a dust buster, maybe I can use it to blow away the other robots. Also, Karen picked up a lamp because she wanted to make something that would sit on top of her robot and have like a defensive perimeter, so she's gonna use the shade as something to hold spikes. I guess we'll see if that works out. Yeah, so we just picked up some random bits of junk and metal and motors just to see what we can do.
So back in high school when I used to do theater, I was doing props, and I discovered that I have a pretty good ability at finding alternative uses for random objects. So going into Dig and Save, I just kind of had a general idea of what I wanted to accomplish and not specific items that I was looking for. And so I knew I wanted to be able to have a ring around my robot so that the balloons could be inside and there would just be pokey death surrounding my robot. And when I found the lampshade, I was like, oh, this is great, because then I have already a fixture that I can use to attach the circle, and it'll keep it up and around and away from the balloons. So I knew it was gonna work really well. I was excited about that one.
This is my weapon, I think. Pretty scary, huh?
What's gonna be on the other end of it?
Death. So what I'm doing is right now I'm actually printing a coupling for it. This is actually a 3D filament guide tube that I immediately took off my printer and didn't use.
Okay.
Because I don't like them. And I've put through it some spring wire.
Okay.
See that? Well, it's not spring wire, it's a spring.
Right.
That we were going to use for a project we never did. What I'm thinking about doing is putting a coupling on either end of this, right? And then running just a piece of piano wire or some sort of stiff solid wire through it and then make it reciprocate like back and forth. So I have a mechanism back here that goes like jig, 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 right?
So like a cam on the other end?
Yeah, so it's basically like a scorpion tail. The reason I'm doing that.
So what are you going to use to hold the end to maneuver it?
There'll be a cam here, like where my fingers are, that has a servo.
Okay.
And the reason I'm doing that is so the weight of the motor doesn't have to be moved. Only this has to be bent.
Gotcha. So I didn't want to drill any extra points into my robot frame, so I'm trying to use holes that already exist, and there's one that's big enough in the center of the back of my robot, but I want my spiky ring of death to be centered over my robot, so I had to heavily modify the brace that I got from the lamp. So I'm using a lot of the pieces from the lamp, the washers and lock washers, things like that. And hopefully I have bent this in a way that it is more centered now and still level with the ground, so all of my spikes will be evenly distributed. Let's see. Oh, that's way better. Oh yeah.
Well, I have reconfigured the XB connections to the transmitter and the receiver. Instead of going through the software serial, I have them connected right up to the hardware serial. Seems to be a lot more reliable. It's quite an improvement. Should we take it for a spin?
Do it.
All right. Literally spinning. Spinning left, spinning right, backwards, forwards, spinning out on the table. It's pretty awesome. So I got this set up for Miss Corbeil now. Actually, I have to make her a beefier battery pack. I'm gonna button it all up and I'll pass it on to her, and then I will get started on my own transmitter and receiver configuration. Well, after I built that controller and receiver configuration for Mr. Beal, I figured I would need some sort of way to control the machine that I make. And I thought it'd be cool to do something with Bluetooth. And we got some Bluetooth dongles, but then I realized that the Intel Edison supports Bluetooth, not only Wi-Fi, but also Bluetooth. I thought, oh wow, that's cool. Do we have any Bluetooth controllers? And lo and behold, the PS4 controller can connect to the Intel Edison via Bluetooth. I thought, wow, that's really cool. I don't have to build another controller. It gives me an opportunity to flex my legs a little bit more with the Intel Edison, because we're gonna end up using that in a future project. I'm removing headers from the Intel Edison mini breakout board. It takes a lot of heat because the board is very thick. The solder sucker helps remove the last bit of solder from the vias. Now I'm making an 18.5 volt battery pack for Mr. Beal. I'm soldering 18650 battery clips that came from Newark onto a section of proto board. The batteries are connected in series. So I've got the PlayStation 4 controller paired with the Intel Edison through Bluetooth, which is really cool. And I have a little program that I wrote which will light these two LEDs when I press either of these buttons. Da 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 da. That's really cool. Okay, so what I gotta do next is figure out how I can interface the GPIO of the Intel Edison with the motor controller. And Intel Edison is running at 1.8 volts, the GPIO is. The motor controller has 5 volt logic. I want all the motor controller pins to be 0 or pulled low. So what I'm going to try to do is connect the GPIO of the Intel Edison to a PNP transistor, and then the PNP to 5 volts. I'll connect the motor controller to the collector, the Intel Edison to the base, and the 5 volts to the emitter, and then also the collector to a 10K ohm resistor and to ground. Then I'll be able to pull the motor controller high. When I send a 0 on the GPIO of the Intel Edison, it should then allow current to sync, which would make the motor controller go high. And I go 1, it should turn the PNP off. The GPIO would go to 0. Ground, however you want to say it. And what I need to do here is I'm just going to wire up a test first, and if that works, then I'm going to try and level up a little bit and maybe see if I can get one of the motors to spin with the motor controller. But not only do I have to wire everything up here, I then need to power up the Intel Edison, SSH into it, and modify some code a little bit to see if I can get it to work. Now, I'm gonna get to it.
All right, I've got the servo here, and I have a spare servo connection on the RC plane remote that I can hook directly up to this and control it with the left control stick up and down. What I wanna do is I wanna mount the servo like this, and then have it run my scorpion stinger, right? So my stinger will go like this, and it will attach to the servo. And then I wanna put almost kind of like just like a slot, you know, I'll 3D print like a slot here. So when the servo turns, it will move the stinger. So again, my reason for wanting to do it that way is I want all the weight of the motor mechanism to be on the robot. The only thing the servo has to move is this flexible tube. And once I have that rigged up, the next thing I have to do is find like a piece of piano wire or something that will fit inside of this. And I'll sharpen the point of that, and that'll actually be my weapon. All right, I don't know if this is gonna fit. I just resurfaced the 3D printer, so not sure if things are gonna fit yet. It kind of fits. Okay, here's the servo mount that I printed. I'm going to attach the servo to it and then attach it to my robot base. I've got some other stuff printing as well. I don't think I'm going to make a reciprocating spike. That's kind of overly complicated, but it's still gonna be a moving spike arm. So my first idea was to make a reciprocating spike. There'd be a motor with a cam and the spike would move back and forth. I thought it would look intimidating, but then I realized it's kind of pointless because the robot can move back and forth. I could just have an inert spike and drive it into something. So that's where I came up with the flexible tubing with spring inside of it. But it was almost like a little too limp. It was like, bloop. So what I did was I 3D printed some stiffeners to basically, you know, keep it a little bit more stable. Because when you put the weight at the end of it, that causes it to droop over. And I also put the servo in such a way that when you can go this far back and also all the way down. So you can be like, whew, whew. So once you get a good motion going, you can like basically, hopefully whip the other balloons into popping.
So in a previous episode, we were talking about salvaging, and Ben and I were talking about how you can salvage the nichrome wire from a toaster or a toaster oven or any other appliance that has a heating element. And so I spun a toaster And it reminded me that heat is a great way to pop balloons. And so I decided to grab one of the toasters and salvage the nichrome wire out of it to turn it into a hot poker weapon. The inside was really interesting though, because it looked like the whole case, the inner enclosure that was metal, it looked like it was stamped sheet metal that it had a really interesting way to attach, where it had these tabs that essentially when it was assembled, they would just like bend over these tabs to keep the whole frame together. So I thought that was really cool. That was something I didn't know before. So all I had to do was retwist those tabs to get them straight so they would fit through the slots again, pull off those end pieces and expose my nichrome wire that I was able to salvage to use for my hot poker weapon.
It's time for a tech timeout. Okay, we're going to do an unboxing of the Robox 3D printer. This is available on Element 14, and they sent us one for us to take a look at it. You ready, guys?
Yep.
We're comparing the times between Felix's knife and Karen's package opening tool. Let's see who wins. That was pretty cool when Wonder Woman cut a car in half. Oh, what's that?
Micro manufacturing platform.
Ooh, I love it when things come in bags, because then you have like an extra tote bag after you get a cool device.
What is this? Oh, it's like a USB stick?
I think it's a scraper.
So it's a scraper, no, there's no rough edge to it. Maybe it's used
it's a
for
card.
leveling the bed, and also has a USB stick on it.
Do you need some high temperature synthetic oil lubricant?
Actually, that's pretty useful. We could put that on all the printers.
Cool.
Cleanup tools.
Yay, tweezers! It's
A nice set of tools.
Ooh.
Oh.
Yeah, there's a couple gouges and like a chisel and
So there's a bag. Maybe this is so you can carry it around.
Yeah, take it to printing parties.
it might be actually cheaper than wrapping it in plastic.
It's not as big as I thought it would be. I've watched videos on YouTube. Do you bleed? So this has spools with data inside of them. However, you can stick in whatever plastic you want. Oh, that's pretty well done. Look at that. Watch.
All right, I'm gonna do it.
Oh, light came on.
Hey, check this out. This slides.
Oh,
Oh, neat. So it can be replaced. Well, so do the other ones.
well, that's probably so you can easily pull your parts out.
Ah, how about that, huh?
Yeah, and then if this flexes, which it does, yeah, it would make it easier to pop them off. Before attempting to load filament, it's advisable to cut the end at a right angle. Keep sticking it in there until you feel the filament has been grabbed. I wonder, how does it get to the head? Oh, whoa,
It's doing something.
the machine's coming alive. There it goes. Whoa, it's really pulling it. Oh, it's probably a Bowden style extruder where the extruder motor is here and it presses it into the nozzle there. So that means the thing that actually extrudes the plastic, the motor isn't here, it's back here. That's how like most Delta printers work and the Ultimaker. Oh yeah, I think what this one does is it has two nozzles and they have different diameters. So we can use one of them for coarse parts of the print and the other one for fine parts. All right, we got our first print out of the machine. It's this little robot. Yay, what do you guys think?
It's so cute.
We were gonna print a bigger one, but that would take too long, so we did the small one.
It's a captivating little machine.
Yeah.
I like it. What do you think of the,
Print quality?
yeah.
Yeah, I mean, there's nothing really to say about it. It looks good. What I mostly like is the fact that it self-levels. Like every time it starts a print, it takes 8 samples. Actually, no, it takes 9 samples
yeah.
from around the board. And then it would use that, not to actually physically move it, but to actually compensate in software, which is good because the hardest part of any printer is getting the bed to be level. Okay, so this is the Robox 3D printer made by Cell. You can buy this on element14.com, and we'll use it in future episodes and keep you posted on how well it works. It's created a robot invasion already! And now, back to the build. I 3D printed this clip for the balloon. I'm gonna attach it to the table and test balloon popping. So I can test the clip and my robot at the same time. So here's a small party balloon, insert it into the clip. That's how we'll attach them to the robots. I'll turn on my machine of death and let's see what happens. Dun, 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 dun. Oh no, Mr. Balloon. There it goes. Well, the clip worked, my arm works, so I'm gonna add some more defensive and offensive weapons to my robot. So I wanted a defensive thing in the back of my robot, so I got a box of 2.5-inch long screws and I measured them and drew them in the computer, and then I made some wooden pieces to hold them. So the first piece had slots for the screws themselves, and the second piece actually held them in place. And then I was able to bolt that to my main wood frame, and now I have a stiff barricade of screws in the back of my robot. It looks like something from that Mad Max movie. Okay, so I cut a piece of this nichrome wire out, right? And let's see how much resistance is in it. See, there's a layer of oxidation on it, so we have to kind of, oh, you know what we should do? Let's grab a knife, scrape it.
Here, I know you like playing with your X-Acto knives.
Oh, it had some toast on it.
Is there butter burned on?
1 ohm of resistance.
Woo!
Not much. Okay, so how many volts is your robot gonna be?
14? 18? Can I just have an auxiliary battery pack for my weapon?
Oh, that's gonna draw a lot of power.
Then maybe I need to either,
Well, we could use a power resistor in line with it. So 20 volts divided by 1 ohms is 20 amps. We could just hook it up to a power supply and see if it gets red hot, because usually it does get red in the toaster, right?
yeah.
Yeah, let's try that. Of course, the thing to think about is, yeah, this is just one piece. There was like, what, 4 of these probably?
3.
And
one is double-sided.
the current was flowing through all of them. So we're only gonna put the current through this one, which means this one's gonna get hotter faster than the rest.
Right.
Well, what's the worst that could happen?
It's not like we could burn the shop down.
Okay, now we're doing this with the bench power supply at 18 volts, which is closer to what Karen's robot's gonna use. However, I'm not sure if this power supply will have enough current carrying capacity. Well, let's just see what happens. 3 amps? Whoa, that's getting a lot brighter. Bring that balloon over here.
It's less than it was with the batteries. It's not even breaking 120.
We might be pushing the limits of the, whoa! Power
It
supply.
worked!
Yeah, so Miss Corbeil wanted to utilize a hot poker, and she has some nichrome wire that she salvaged from a toaster. And we found out that it was drawing a lot of current, and we figured we could set up a auxiliary battery pack to close the circuit for the nichrome wire. And we're doing that with a 5-volt logic relay triggered by a tip 102.
I had this extra weapon idea to make a hot poker, but having it at a fixed point wasn't gonna do me any good because I need to be able to aim wherever their balloon was. So I knew I would need to create a mechanism that would allow me to move my poker up and down. And in the past, I've taught kids how to make cranes out of popsicle sticks and string and simple craft materials. So I already knew that I could use a simple pulley and screw system to wind some string to move my crane mechanism up and down. So I figured I could use a servo motor to kind of be able to aim my weapon a little bit, and it was kind of already built into the controls, so I think it's gonna work really well.
So I created my death flail and my defensive butt spikes. Now I'm adding a third thing, which is the spinning spike tube. So I designed a mount for the motor, which goes into my wooden frame. And again, that's why I added the wooden frame, because I wanted specifically spaced out holes that I could attach accessories to. Then I printed a kind of a plus-shaped tube that I could drill holes into and put more pins in. The reason I did it manually is because it's a lot faster to just drill holes with a drill than it is to model them in the computer. And you know, I've done a lot of 3D printed parts of my robot, and people are starting to call it the corporate bot, but hey, you know, that's how my mind thinks. I have a 3D printer, I'm gonna use a 3D printer. I'm gonna use my new welding helmet for eye protection, just in case anything goes flying off. Where is the map to Skywalker? I'll never talk. One of you will talk. I guarantee it. Who's going to crack first? Never! No, don't use that scorpion whip. Very well. But I have other ways of making you talk. Dun 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 dun. What? Oh, dun 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 dun. What? Oh, you are tougher than I thought you were. So, are you going to talk? I'll never betray my balloon people. Very well. Die. No! If my robot could talk, what would it say to the other robots? I must break you.
Okay, so our weapons are mostly done.
Mostly.
So I think we made pretty good progress.
Yeah, so in the next episode, part 3, the conclusion, we're going to finish up the weapons, test out the robots, put some more defenses on, and then decorate them. And then it will be time.
And then fight! Or fight! Yeah, right? So, who do you think is gonna win the final epic battle? Let us know on the Element 14 community on element14.com/TBHS.
Where you can also read about other upcoming episodes, builds, and special events. We'll see you next time for the big finale. What are we gonna call this album, Adele? How old am I this year? 25? 25. Sing it. Packers!
Let me tell you about an exciting opportunity that people are talking about.
So Karen, in the previous episode, we started making some Hackbots.
Yeah. This is gonna suck.
It's like 3 balloons? That sounds like Mario Kart.
Does it? Okay. I don't know why Jesus on Jesus. It's just.
Jesus on Jesus.
It's like Christ on a cracker.
That's good. The Ben Heck Show is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com.